Alright, John, this is the last section of the chapter 13 stuff. This time we have trig equations that use identities. After I finish this, maybe I'll try to find the practice test that you're going to have to go over anyways, so maybe I'll go through some of those with you and make a video. I just want to make sure that you have enough practice doing this stuff before you take the test, okay? So trig equations that use identities. And what I mean by identities are maybe the Pythagorean identities, or maybe one of those equations that we learned that are on our reference sheet, which are right here, which we learned in the last unit. Functions of the sum of two angles, the difference of two angles, double angle, half angle. So what I want you to do right now, John, if you haven't done so already, I want you to grab a reference sheet. If you need to print one, go ahead and print one, but have it out in front of you just so that you can use it while we're going through these, okay? So let's see. We have 2 cosine squared theta minus sine squared, or minus sine theta is equal to 1. Okay, so it looks like it wouldn't be that big of a problem, but what is different about this equation compared to the last ones? All the other equations that we've done so far, they've only had one variable. They've only had sine theta in there, or they've only had cosine theta or tangent theta. This time I have a cosine here and I have a sine here. I don't know why I can't draw a straight line. It's a problem. Okay, well, why is that a problem? It's the same thing as trying to solve an equation that has like an 2m squared minus n is equal to 1. There's two different variables. There's two different things that we're trying to solve for. It doesn't work. You can't do it. So what am I going to have to do? I'm going to have to use one of my identities so that I could make it this whole equation all in terms of sine or all in terms of cosine. So think back to the test that you probably just took. Is there a way that we could rewrite one of those variables so that we could, fix this whole situation? Well, the squared sign always kind of gives you like a hint, like, maybe you could do something with me. Cosine squared theta is equal to 1 minus sine squared theta, isn't it? And look, now I have a bunch of things that are in terms of sines, and now my problem is fixed. Here's what I will warn you about. Whenever you take something and replace it with something else, always put whatever you wrote in parentheses like this, because more than likely you have a term out front like this that you're going to have to distribute. So if you don't put those parentheses, you're not going to remember, oh hey, I have to distribute whatever was out front. Okay? So you see what I just did? I took something that had two different variables, oh my gosh, I can't talk, and I made it so that only has one variable, which is awesome. Now I'm going to go through and distribute. So this is 2 minus 2 sine squared theta minus sine theta is equal to 1. Okay, so I'm just going to rearrange this so that it's in the right order. So this is negative 2 sine squared theta minus sine theta, and then plus that positive 2 is equal to 1. Now, I need to probably do circles and squares because I have a leading term out front, but the first thing I need to do is set it equal to 0. So I'm going to subtract 1 on both sides. Negative 2 sine squared theta minus sine theta plus 1 is equal to 0. Okay, now the only other thing that I will tell you is that Ms. Tompkins said whenever you guys are going to do circles and squares or factored or whatever, she always wants this leading term to be a positive number. So the fact that it's negative right now is not good. What we need to do to fix that is change all the signs. Multiply everything through by -1, or just switch all the signs. So instead, this is going to be a positive 2 sine squared theta plus sine theta minus 1. Okay, now I can do circles and squares. So I think that you were originally said that you just kind of like to do guess and check. That's fine at this point. Sit there and figure out which way works best for you. I'm going to try to do circles and squares, even though I'm kind of horrible at this. But let's see, I need the numbers that multiply to positive 2, so 2 and 1, and then the numbers that multiply to negative 1. So actually, I'm going to make that positive and this negative. So then what I do is take 2 times 1, which is 2, and then 1 times negative 1, which is negative 1. 2 minus 1 is equal to a 1, which is what I have right here. So that worked. That means that my terms go like this. You read them across. So this is going to be 2 sine theta minus 1 times sine theta plus 1. Remember that our variable is sine theta, not x. So don't get confused when you're writing this stuff. Okay? See, that's where it gets into not being fun. The first thing that we did up here was we rewrote the cosine in terms of sine. So that's kind of like the easy part. You have to figure out, all right, how am I going to make it so that all these variables are the same thing? And you have to go through and do the work. See how it's not always that fun. But, I mean, it's not that bad just because you've already done all this stuff before. Okay? So, if I have 2 sine theta minus 1 is equal to 0, then I'm going to add 1 to both sides. So 2 sine theta is equal to 1. So sine theta is equal to 1/2. Alright? So let's see, because sine theta is a positive value, all students take calculus, let's figure out where my answers are going to be. My answers for this part. Positive, so in the first and the second quadrant. And then this is the one that Miss Tompkins wants every single person to memorize. What is theta when sine is equal to 1/2? Theta is equal to 30 degrees. So the first one in the first quadrant, theta is equal to 30 degrees. And then in the second quadrant, this is 180 minus theta, so 180 minus 30 is 150. Awesome. That solves that problem over there. Okay, now let's go over here. I have sine theta plus 1 is equal to 0, so sine theta is equal to a negative 1. Now, remember, John, anytime your answer is a negative 1, a positive 1, or a 0, that's not a square. It's normally a circle. Messing everything up around here. Cut. Goodbye. Thank you. I need my unit circle back. Thank you. So, on our unit circle, sine is my y value. Where is my y? A negative 1. Y is a negative 1 right here, which is 270 degrees. Okay, so those are my 3 answers, which is awesome. Let's see how long that took us. Only 9 minutes to do that one problem. It's probably because I'm going really slow. But, alright, let's move on to the next one. 2 cosine theta minus 2 sine theta plus 2 is equal to 0. If you just listen to those videos from the previous chapter, which is chapter 12, this should be like standing out really, really well. You should notice, oh hey, I know what that is. That is a double angle. Double angle, double angle, double angle. And that is one of the things that we have on our reference sheet right here. Functions of the double angle. Nice. So, I clearly have a problem right now. I have a cosine and I also have a sine. I need to only have one variable in order to do this problem. So, you remember how I told you that cosine of a double angle has 3 different equations? And it doesn't matter which one you pick, they're all going to work out the same way. Except for, in this case, think about it. We have, you know, a sine and a cosine. We want to try to get everything in terms of one variable. So why not pick the equation that only has sine in it? That way my entire equation only has sine in it. So instead of cosine of 2 theta, I'm going to write this one, which only has sine. 1 minus 2 sine squared. It has a, but we're using thetas, so sine squared theta. The only reason why I put that in parentheses was because I want you to get into the habit of putting something in parentheses if you substitute it into an equation, just in case there was like a 3 out front. Then you'd know to distribute that 3 through. Okay? Plus 2 is equal to 0. Now, I'm just going to do the same thing I did before, rearrange all of this so that the sine squared comes first. So this is negative 2 sine squared theta minus 2 sine theta. And then I have to just combine those like terms. They're on the same side of the equation, so it's not like I'm adding or subtracting to combine them. Some people were getting confused and maybe doing like a minus 2 here and a minus 2. And I was like, no, what are you doing? That's horrible. Don't do that. They're not on the opposite sides of the equations. They're on the same side. So all you're doing is combining them. I have a 1 here and I have a 2 here. That makes a total of 3 constants. 3 is equal to 0. Now, I have a leading term of 2, meaning I'm going to have to do circles and squares again. But first things first, I have to fix this. There's a negative out front, which we don't want. So I'm going to have to change all the signs. This is a positive 2 sine squared plus 2 sine theta minus 3 is equal to 0. And now, yay, circles and squares. Fantastic. I love circles and squares so much. Except for I really don't at all. I need 2 numbers that multiply to 2 and then 2 other numbers that multiply to negative 3. So I'm going to do 2 and 1. And then I'm going to do 3 and 1. And that's not going to work because 2 times 3 is going to give me a 6. And that's going to be a negative 1, so that's a 5. That doesn't work. But what about if I switch them and I do a 3 here and a 1 here? So 2 times 1 gives me 2. 3 times 1 gives me 3. That still doesn't give me a 2. So you know what that tells me? That tells me that I would need to use the quadratic formula in order to solve this. So I'm going to stop this video right now and then do another one for you.